So which cells does he lack?
Cone.
Night blindness. For night blindness, which cells
Rod.
does he lack?
Rod cells.
Rod cells. And for color blindness,
Cone.
cone cells. So color blindness means he has less number of the cone cells. Night blindness means he has less number of the rod cells. Okay. So some people, they have color blindness. Color blindness is by birth, which means there are certain types of the cone cells which are missing in his eyes. There are certain cone cells which are not there in his eyes. So that is why he will be suffering from color blindness throughout his life. So some people are colorblind because they lack some types of cone cells. Certain cone cells, they are absent in their eyes. Okay. In the last class, we had also seen these three eye defects. We had seen astigmatism and presbyopia. We have seen astigmatism, presbyopia, and cataract. So what is astigmatism?
Sir, it is an eye defect in which a person is unable to focus on vertical lines and horizontal lines also.
Yes. And what about presbyopia?
When the person has both myopia and hypermetropia.
Hmm?
Or
The person they are having yes, Abhinav?
cataract or presbyopia.
No, presbyopia.
When a person has both myopia and hypermetropia.
Yes, a person is suffering from both myopia and hypermetropia. And which people suffer from presbyopia?
Old.
Old age, old age people suffer from presbyopia. Very good. So during presbyopia, what is the cause of presbyopia? Ionija, what is the cause of presbyopia?
Sir, it leads to weakening of ciliary muscles.
Yes, it occurs due to weakening of the ciliary muscles. The ciliary muscles, they become weak and they are not able to adjust the focal length of the eyelids. That is why we suffer from presbyopia. Then what is cataract?
Milky tissue grows in front of our eye lens, sir.
Yes, a milky tissue grows in front of the eye lens, which makes the vision cloudy. So it initially makes the vision cloudy, slowly and slowly blocking all the light, and loss of vision can also occur due to cataract. Okay. This is also an old age problem. Cataract is also an old age problem. How can cataract be corrected?
Surgical methods.
By?
Surgical methods.
By surgical methods, yes. Cataract can be corrected by surgical methods. And how can presbyopia be corrected?
By wearing certain glasses which have concave and convex lens.
Yes. So by using bifocal lenses, if we use bifocal lenses, we will be able to correct presbyopia. Okay. So this was all about human eye and their correction. Okay. Now the next is colorful world. Now we are moving to the next part of the chapter, that is the colorful world. So in the beginning, I told you something about light. That our light, which we see our light, we call it as the visible spectrum of the light or the waveguide. Okay. So our light, or which we call as the electromagnetic wave, it consists of gamma rays. We have gamma rays, X-rays, UV rays, which we call ultraviolet rays, UV rays. Then we also observe the visible spectrum by which we are able to see. So we have visible spectrum. After visible spectrum, we observe certain other rays also. We observe microwaves in we observe here infrared, microwaves and radio waves. Okay. So microwaves and radio waves, all these light rays, they travel with the same speed. All the light, it travels through the same the speed of light is equal to c, which is 3 multiplied 10 to the power 8 meter per second in vacuum. Okay, all these, whether it be X-rays, gamma rays, UV rays, none of them travel the fastest. None of them travel with a different speed. All of them travel speed. All of them travel with the same speed of 3 times 10 to the power 8 meter per second. Here in this chapter, we will only be talking of this part, visible spectrum, which we also call as the VIBGYOR. Okay, so if you spot VIBGYOR as, let's see the VIBGYOR. So VIBGYOR or the visible spectrum, it consists of 7 colors of light. Just 1 minute. Okay, see the VIBGYOR. Here we have the split of VIBGYOR spectrum. We'll also see their frequency and wavelength. That is what we want here. See, this chart, it lists the VIBGYOR in its, below it you can see the wavelength of the light is written. See here, you can see this is the VIBGYOR or the spectrum of light. You have the wavelength of light written below it. The violet color, the color of violet, it starts from 350 nanometer and the color of red color goes up to 750 nanometers. All these measurements which are given, they are in nanometers, and these measurements, they are the wavelength of light. Which symbol do we use to represent the wavelength of light?
Lambda.
Yes, which symbol do we use to represent the wavelength of light?
Lambda.
Lambda.
Lambda. So lambda is used to represent the wavelength of light. Then we have also used a term frequency here. Okay. So out of violet and red, which one has a greater wavelength?
Violet.
You can see everything is written. Violet has a wavelength of 400 nanometer. Red has a wavelength of 800 nanometer or 750 nanometer. So which one has a greater wavelength?
Red.
Red.
Red has a greater wavelength, right? And in terms of frequency, if you talk of frequency, so violet will have the maximum frequency and red will have the minimum frequency. In terms of frequency, violet will have maximum and red will have minimum frequency. Okay. So our splitting up of white light into its constituent colors is called as dispersion. So in this chapter, we are going to study the phenomena of dispersion and scattering of light. So these are the two phenomena which we will be studying in this chapter, dispersion and scattering. In the previous chapter, we have studied about reflection and refraction of light. In this chapter, we will be studying about dispersion and scattering of light. So these two are different phenomena. Dispersion means splitting of white light into its constituent colors. When we say a white light split into its constituent colors, so this means it is dispersion. Dispersion means splitting of white light into its constituent colors. Is called as dispersion of light. So here in the diagram, you can see about the dispersion of light. So this diagram, the diagram gives you the dispersion of light. Here we observe a white color light falls on the surface of a glass prism. You can see a rectangular glass prism is taken, and on the rectangular glass prism, you have white light falling on this glass prism. Then that white light splits into its constituent colors. Here we see the white light has split into its constituent colors, which are represented here. Okay, so out of the given colors, which color has the maximum bending? Which
Violet.
color has the maximum bending? Violet color. So this is also a point to be remembered when dispersion occurs. So here you will find all the 7 colors, but in opposite order. Like it's not here Vibgyor, it's not like this Vibgyor. This is not the Vibgyor which we observe here. We observe the Vibgyor in the inverted form. The violet bottom. So we observe here Vibgyor, violet, indigo, blue, green, yellow, orange, and red. So this is how we observe here. Violet is at the bottom and red is at the top. So there is minimum deviation that occurs for the red color and maximum deviation for the violet color. Here we observe the white light passing through the glass plate. This phenomena is called as dispersion of light, splitting of white light into its constituent colors. Got it?
Yes, sir.
Okay. One more phenomena here we will see. We'll try to complete the refraction of light through a glass plate. Okay. We have done the refraction of light through a rectangular glass slab. We will observe here that how does the refraction of light occur through a glass prism. Since this is a glass prism, and we will observe that how does the refraction of light occur here. So for that, let's draw the diagram. All of you start drawing this diagram, which we call as the refraction of light through glass prism. All of you must have your pencil and scale with you. So for the refraction of light by a glass prism, what are the things that we observe here? So here I'm drawing a glass prism. So let this be a rectangular glass prism, and suppose white light falls on this surface. So this is your A, B, C. We have a ray of light, a white light, coming and falling on this surface. Okay. Now, in which direction will it be deviated? Just 1 minute, 1 minute. Okay. So let's observe now. See, we have a ray of light which is incident on the surface AB of the rectangular glass slab. Oh, sorry, of the glass prism. At this point, we will draw the normal to the surface. and we will observe that where does the ray of light bend. Class 10th, all the class 10th students, they are very smart. They never keep their camera on. Because if they keep their camera on, I will be able to observe them. Some of them, they vanish during the classes. Keep the camera on and vanish during the class. Okay. See, you have the normal. This red line which we have drawn, we call this to be the normal to the surface. This is the incident ray, and the angle between the incident ray and the normal is called as the angle of incidence. Now, the ray of light which was coming, it was supposed to go straight. Okay. So this ray of light which we had seen here, which was coming as a ray of light. So this is supposed to go straight, but refraction or bending of light occurs here. And because of the bending of light, in which direction will it bend? Okay, where shall I make it bend? See, you will tell me. So shall I make it like this, or shall I make it above this? Where will it bend? Siddharth,
So
can you tell
towards the north.
where? Okay, I'm drawing this. So shall I make it like this, or shall I make it like this? Which one is correct? I'm drawing the two light rays. So which one should be there? Should there be this yellow line, or should there be this blue line? Which ray of
Blue
light
one.
should be?
Blue
The
line,
blue
sir.
line. Okay. It has to be the blue line and not the yellow line. So this blue line represents the ray of light which is refracted. And when it reaches the other surface, see, when it reaches the other surface, here again it bends. Again, refraction will occur. So we need to draw another normal at this surface. So at this surface, again we draw a normal, which means a perpendicular to the surface at 90 degree. So this is another normal. Now, where should I draw? This is my emergent ray. So from here, the emergent ray should be drawn here or above.
Away from the normal, towards the down.
Yeah, away from the normal. So here I am, this is towards the normal, and it should be drawn below something like this, which means away from the normal. Okay. So here an important question comes here. This is our angle of incidence. This is our angle of emergence. Okay. And if I trace this ray of light back, if I trace the ray of light backward, so the ray of light, it meets the previously incident ray. The emergent ray meets the incident ray at a point O. Can we see that the two light rays are meeting each other? Yes. The two rays of light, they seem to meet each other. The angle found between them we call as the angle of deviation. This angle is asked a number of times, angle of deviation. Huria Ishaq, your name, by what name you are being called? You are called as Huria or Ishaq?
Huria.
Okay, we'll call you Huria. Okay. Thank you. So here, angle of deviation. Deviation means by how much degree the incident ray has deviated or bent. Okay. So the incident ray which was traveling like this has now bent and has emerged like this. Okay. So what is the angle of deviation? We observe here the angle of deviation between the two surface, between the two rays. as angle delta, which is marked here. We mark it as delta. So delta is the angle of deviation. Okay. So can all of you make this diagram? Is it possible for all of you to make the diagram?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes, sir.
you should be able to draw the diagram, mark incident ray, emergent ray, and angle of deviation. Okay. So this diagram shows the refraction of light by a glass prism. Okay. Now two things again. We are observing here refraction by glass prism. In the previous, here we did dispersion by a glass prism. So for this question, what results are expected if I put an inverted glass prism over here? Suppose I put an inverted glass prism like this. I have to use this one only. And let me put an inverted glass prism. So what result do you expect? Suppose I place this prism over here. So if I get a light on the other side, so will I get again the complete spectrum?
No, sir.
No.
Sir, we get white light.
Yes. So here you can observe we will be getting here a white light. Any reason why we will get a white light? Yes, any reason why we will get a white light if I place this prism over here? And I will not get a dispersion of light.
Yes.
So why?
Yes, because multiple rays of light again meet each other and become a single white light again.
Okay, see, if you observe this complete, see, if you observe this completely, can I say that it is a glass prism? Does it appear like a glass slab? When
Yes.
both the prism are combined together, does it appear like a glass slab, something like this, a parallel figure, parallelogram?
Yes, sir.
And do we have opposite faces parallel to each other?
Yes, sir.
Yes. So here, if one of the prism disperses the light, the other prism recombines all the light together. Okay. So here the other prism, it recombines the light and finally you obtain here a white light. So all the rays of light which are falling from here, all the rays of light, they will be combined together here again and you will get a white ray of light which will be parallel to this. Just exactly what we obtained in the case of a glass slab. Okay. Anyone having any doubt regarding dispersion of light? Dispersion and recombination?
No, sir.
Yeah.
Or can any white light be dispersed or only the natural white light?
Okay. You can disperse any white light. Any white light can be dispersed. Okay. Because the light will be white. If you say white light, so white light means it must constitute of the 7 colors. Okay. When we say white light, it means it is constituted by the 7 colors. Got it? Any other doubt?
No, sir.
No, sir.
Okay. So based on the phenomena of dispersion, so for dispersion, opposite faces should not be parallel to each other. If the opposite faces are parallel to each other, then we will not get dispersion. Okay, we'll get the same light which we are throwing on it. So here, that is the reason if you place two prisms, one above the other inverted in this form, you will get a white light again. That will be recombination. In the similar way, we can observe the formation of a rainbow. So how is a rainbow formed?
The water droplets pass, I mean, the light passes through the water droplets and then it turns into rainbow.
Okay. Okay, what is the shape of rainbow?
Circular, sir.
Circular?
Curved,
Curved shape.
curved shape.
Curved shape. Okay. See, about the rainbow, there are two important things about the rainbow. First of all, a rainbow consists of 7 colors. Huria, if you are not comfortable, you can turn off your camera.
Thank you so much, sir.
Okay. So for what is formation of rainbow? During the formation of rainbow, we observe two important things here. One thing we observe during the rainbow formation is the 7 colors. That is, the rainbow consists of the 7 colors. Then the second thing we observe the shape of rainbow. Okay. So we observe the shape of rainbow. Why it is always a curve? Why not a straight line? Can you think of why a rainbow is not a straight line? Why it is always curved?
Sir, because
Sir,
there
when it rains, no sir, then the light, then that white light will pass through those rain droplets, sir, and then that droplets act as a prism, and then it forms a rainbow, sir.
Okay.
It's not a triangular prism, right, sir? So the water droplets are not in the form of a triangular prism.
Okay. See, a rainbow is actually circular in shape. I will show you. If you observe a rainbow from an aeroplane, this is what we know something a rainbow to be. This is what we know the rainbow, right? But if you observe the same rainbow through an aeroplane window, you will get, see here, this is what you are getting a curve. Okay. But if you observe a rainbow from the window of an aeroplane, you will get a complete circle. Let me show you. So let me show you how does a rainbow look like if you observe the rainbow from an aeroplane. Okay. So you will be able to observe it to be a complete circle, something like this. See, this one, a perfect circle. You will get a complete circle. A view of rainbow observed from an aeroplane will be a complete circle. So actually, the rainbow is circular in shape, but what we are observing from here, what we observe from here is not a complete rainbow. We observe just a part of the rainbow. Okay? So why it is circular in shape? The shape of the rainbow, it is because of the critical angle for water. The whatever is the critical angle for water, so it depends on the critical angle of water, or you can say due to the shape of the earth atmosphere. Due to the shape of the earth's atmosphere, we are able to observe a rainbow which is in the circular shape. Okay, and why it appears in 7 colors? That is because due to the splitting of the white light, because of the splitting of the white light in presence of water droplets or moisture. So you will observe a rainbow if you have sunlight just after rain, or along with the rain you should have the sunlight. So these two things should be there. You should have water droplets in the atmosphere, and along with the water droplets you should also have sunlight. So you should have sunlight and the water droplets both being present in the sky. Then only you will be able to observe a rainbow. Got it? So the water droplets, they will help in splitting up of the light, and you should have the light to be split up. If there is no light, so how you will observe? You are not going to observe the rain. Anyone having any doubt regarding this? Yes?
No, sir.
Anyone?
No, sir.
No. So we
Sir.
have studied, yes? So today we have seen the phenomena of dispersion of light. We have seen today the phenomena of we have seen the different eye defects. Okay. So during the dispersion of light, rainbow formation occurs. The phenomena responsible for dispersion of light. Which phenomena is responsible for rainbow formation?
Refraction of light.
Refraction or
Dispersion.
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 Dispersion, sir.
So if you are asked which phenomena is responsible for this, so these are the three things that you should be knowing. Dispersion of light is responsible for the formation of rainbow. Refraction of light is also responsible for the formation of rainbow. Okay. And reflection of light also. Okay. So since there are no doubts, we can end up right now. Bye all of you. Tomorrow or in the next class, we will see scattering of light. Okay.
Thank you, sir. Bye, sir.
Thank you,
Bye.
sir. Bye, sir.
Thank you, sir. Bye.
Thank you, sir.
Goodbye.
Thank you, sir. Bye.